let's take a look at a couple of examples of how to draw the reciprocal function. Now, in a previous video, I showed you how to graph the reciprocal of f of x equals to positive x. So now I'm going to show you how to graph f of x equals to negative x and then take its reciprocal. So let's first write the reciprocal function, and that would be y is equal to negative 1 over x. And we also want to find the asymptote. So the asymptote occurs when the denominator equals to 0. So we can see that in this case, there's only one value or one variable. So here we have x equals to 0. All right. Now I'm actually going to try to do this kind of the quick way with our steps. So we're first going to graph the original function, which is a line with a slope of -1 going through 0, 0. So that would be something that looks like this. So I'm going to just draw these and connect these points here. Okay, and then what I'm going to do is now draw the reciprocal. So I'm actually going to use a different color so we can see it. So remember that the first thing is that all the x-intercepts, which is right here, right, that's going to become a vertical asymptote. So I'm going to have a vertical asymptote here, right at x equals to 0. Okay, remember we also have a horizontal asymptote. So let's put that in at the x-axis, and remember that's only for this here right now before we move them, because they can be transformed. We're going to replot where y equals 1, which is right here, and y equals -1, which is here, because those are invariant points. When I take the reciprocal of +1, I still get +1. When I take the reciprocal of -1, I still get -1. All right, so now what we're going to do is that we're going to take the reciprocal of several y values. Now I can draw a table to do this, or I can just do this freehand. So for example, I see that this y value is 2, so the reciprocal of 2 would be 1/2. So I'm going to graph that down here. I won't plot. There we go. So here we have a y value of 3. The reciprocal of 3 is 1/3. So we can see that it's getting smaller. And I think that's good enough, actually. We won't be able to graph any other points. Oh, it doesn't seem to want to graph. All right, let's pick a point going closer to 0. So here I have a point here, which is +1/2. And the reciprocal of +1/2 is +2. So I'm going to graph that point here. And for some reason, my points won't graph today. All right, so there we go. Connecting these points on the left side, you get something that looks like this. And then we're going to do something similarly on the right side. So we have -2, so then our reciprocal is -1/2. -3, our reciprocal is -1/3. And then we'll pick something between 0 and 1. So we have here, this point here, a y value of -1/2. The reciprocal of -1/2 is -2. So that will be plotted here. So connecting my points, I get a graph that looks like this. So to generalize, our 1s and -1s, or where y is 1 and -1, they stay the same. When the graph is getting closer to 0, as in the middle here, the graph actually moves away from 0 when we draw the reciprocal. On the ends here, the graph is going away from 0, and the y value is getting very, very negative or very, very positive. But when we draw the reciprocal, it actually goes in reverse, and it actually goes closer and closer to the asymptote of y equals to 0. Let's take a look at another one. So here I have f of x equals to 2/3 x plus 2. And the reciprocal would be y equals 1 over 2/3 x plus 2. Not very nice, but we'll leave it there or like that for now. To find the equation of the vertical asymptote, remember, we are looking for where the denominator in the reciprocal is 0. So we can say that 0 is equal to 2/3 x plus 2. And then we're going to move the 2/3 to my left side. multiply everything by 3, so I get negative 2x equals to 6, and then divided by negative 2, so x equals negative 3. So my asymptote, my vertical asymptote, is that x equals to negative 3. Okay, let's see if that is true when I graph my line. So again, let's graph our original function first, and that would be 2/3 x plus 2. Has a y-intercept of 2, which is this value here, and then a slope of 2 over 3, which is this fraction in front of x. So we're going to rise 2, run to the positive 3, rise 2, and run 3. Or we can go down 2 and left 3, down 2 and left 3. So we get a graph that looks something like this, which I'm going to connect. Okay, and then let's go through our steps again. So all the x-intercepts, they become our vertical asymptotes. So here we have one x-intercept right here at negative 3, which is actually corresponds to our vertical asymptote here, which we found earlier. So we're going to draw a vertical asymptote at x equals negative 3. All right, and then where y equals positive 1 and negative 1, we are going to redraw those points. And actually, this one should be a little higher up. It should be right there. All right, and then we're going to take the reciprocal of some values, y values. So we have here negative 2. So the reciprocal of negative 2 is negative 1/2. So we'll plot that here. Here we have approximately somewhere in here is negative 1/2. So that will be negative 2. So we get something that looks like this on the left side. And we don't have to plot too many points. 2 to 3 on each side of the asymptote is good enough. So here we have positive 2, so we get positive 1/2. Somewhere in here we have positive 1/2, so the reciprocal of that would be positive 2. So somewhere around there. So again, we can connect our 3 points on this side. And now we have a reciprocal graph.